Okay, so my name is Morgan ZIMMERMANN. At Dassault Systèmes, I am the CEO of 3D Experience NetVibes. So I am in charge of everything that is data and AI related when it comes to our portfolio. I thought I could not start this discussion, because this is about AI, without starting by for whom. And who are the users of Dassault Systèmes that are actually having access to our AI technology. And this is quite simple. It's everyone. Every single users out of our 50 million users. Every single of our customers out of our 370,000 customers across the three sectors of the industry. You know us very well for manufacturing industry, I guess. You probably don't know us in life science. You might not know that 50% of the clinical trials in the world are made with Dassault Systèmes. And you probably don't know us for what we do in the infrastructure sector. So, one point to keep in mind here, what we're going to talk about today on AI is for every single of our users, which is quite massive scale by itself. By the way, AI and virtualization is also the reason why the industry shakers have all selected 3D Experience and Dassault Systèmes. So I've put some examples here on the screen, you know, but all of the manufacturers are humanoid robots. They're leveraging some of what I'm going to show you in the next few minutes to do their humanoid robots. 90% of the manufacturers of electrical vehicles, 100% of the new drug developed by the 16th largest pharmaceutical companies, 80% of next generation nuclear systems are made with the pieces of technologies and virtualization models that I'm going to show you in the next few minutes. And a last introduction comment that I would like to share with you. We trust in what we call the generative economy. So this probably deserves few explanations. Generative economy for us is the convergence of what we call the experience economy. You know, Tesla is not doing cars. And sustainability imperative. This is generative economy. And what we believe is that to serve the generative economy, we need V plus R. So that probably looks quite weird, V plus R. So V plus R stands for virtual and real. Why do we need the virtual world? Because the virtual world is unlocking unlimited experimentation possibilities. It's unlocking the ability to start learning at scale that are impossible in the real world. And when you start combining the power of virtualization with what you can do with what you can see in the real world, you look at the problems through different eyes, and I hope I will convince you of that in the next couple minutes. So now let's go into AI and let's be a bit more specific. Well, that's a very difficult slide. I made it on purpose to make sure no one can actually understand what you see on the screen, so you have to listen to me. At Dassault Systèmes, we don't speak about AI. We speak about generative experience. So some of you might believe, yeah, this is Dassault Systèmes inventing its own vocabulary to say the same thing as everyone else. Well, not this time. Generative experience is about combining two things, science and data science. Science is what you see on the left-hand side. It is the laws of physics. If I drop my phone, is it going to break? Most probably. Because of the laws of physics. And data science is the world of observation, which is what you see on the right side of the screen. Why do we think these two things are important to work together? The reason number one is because with the modeling and simulation, what you have on the left side, you have projection system. You know, when you want to do learning, you need to have ontology. You need to have projection models where you can project all of the data that you're acquiring. The modeling and simulation world is providing us the most advanced representations of complex systems, which we can use to project data. There is no better projection system to understand an aircraft than the virtual model of the aircraft. There is no better projection system of a nuclear power plant than the virtual model or the system model of the nuclear power plant. And this is what we bring to interpret the data that comes from the real world. The second reason is, you know, the guys in the Silicon Valley, their single biggest problem at the moment, well, I don't think we can talk about Silicon Valley here today. Well, the guys in Paris, their biggest problem at the moment is access to data, because the internet is shrinking. It's important to realize that. Why is it shrinking? You know why? Because people have understood that there is value in data. So now you cannot use the entire internet like they did at the beginning to do your learning, because people are restricting the usage of that data. Now if you think about it, with what we have on the left-hand side, we can learn on products that don't even exist yet. I can do predictive maintenance for products that don't even exist yet. That's quite interesting, because we can generate synthetic data that are respecting the laws of physics in the virtual world. So I can generate usage conditions that goes beyond what typical human people would do with their cars or with their aircraft in the virtual world to fuel learning models. Synthetic data. That's, we believe, one of the big point bascule, tipping point. And the last one is with what you have on the left-hand side, you can do modeling and simulation, so you can do what-if scenario. What does that mean? Let's say you do predictive maintenance and you discover that you have a corrosion problem somewhere. If you want to find a solution, it would be great, wouldn't it, if you were able to do simulating new material and the impact of that new material on the corrosion impact. And this is what we can do with modeling and simulation. So that's an important statement. Second statement. You know, if you go on ChatGPT, this is great. You can have access to terrific knowledge and know-how. But this is totally useless if what you want is to build differentiation. So the next important question is, what is the differentiating knowledge and know-how of our customer? You know, and that one is implicit. It's hidden. It's hidden in document. It's hidden in configuration trees. It's hidden in processes. It's implicit in 30 years, 40 years, 50 years of history. But I can tell you, there is massive differentiation in the knowledge and know-how of a Toyota, an Airbus, a Boeing, or a Lockheed Martin. So the next question is, can we unveil, can we reveal that knowledge and know-how? And this is exactly what you see on the screen. Here we have taken a set of car, and we are using lots of AI models to do clusterings and synonymy and similarity analysis and features extractions and so on to actually understand how a car has been built in that specific company, so that the next time a designer is working on a car, he will be able to leverage a past learning to fuel every single of his decision. So let's continue. We have two vehicles that we use, because, you know, discovering the implicit knowledge, that's one thing. But if you do not make it explicit, someday it's useless. So the next question is, how do you make it explicit? How do you make it actionable to every single user? We have two vehicles to do that. One is the virtual twin. The virtual twin is what you see on the screen. And we are projecting on the virtual twin every single piece of data that comes from any single system. That's important. I can give you a very naive analogy to explain what you see. If I give you two Excel spreadsheets, one with location of restaurant and one with location of flower shops, and I ask you to find a restaurant nearby a flower shop. Well, in usual places, most people would find that difficult. Here, probably everyone can do that. But if it's on the map, it's more simple. But think about it. If you have an aircraft and you have 100 million corrosion data and requirement data and regulation data and cost data, they're disconnected by nature. But as soon as they are projected on the virtual twin, they are correlated by nature. So what we do for every of our customers is we are using the virtual twin to correlate and contextualize all of the data that are coming from every single of their system. So that's vehicle number one. The vehicle number two is virtual companions. I mean, I'm sure most of you would call that agents. We don't call that agents, we call that virtual companions. Because we are French. And companion is a great word. You know, for the one of you that are French, a compagnon is a craftsman expert in the factories. A compagnon is a friend. And by the way, a compagnon is part of a community of experts. And this is what our virtual companions are embodying. We have introduced 3 virtual companions, Aura, Léo, Marie, which have specific skills, business skills, engineering skills, and scientific skills, targeting different audiences. What you see on the screen at the moment is interesting. The first thing I'm doing is I'm actually asking the virtual companion to guide me on the best practices for doing welding, leveraging what are the best practices of the industry. But then the virtual companion is also helping me understand within my company what are the incremental best practices on how we do welding in my specific company. Not only that, but then the virtual companion is going to help understand how to use, in that case, our product, Katia. And by the way, because the virtual companion understands the virtual twin, so he understands what you have on the screen, is actually capable of doing the work on behalf of the user. So in that case, he's doing the topology optimization of the welding point on behalf of the user. So this is a new nature of virtual companion that is not only capable of revealing the knowledge, it's also capable of doing the work, taking the right actions on behalf of the user. So now if you've listened to me, you have probably understood that the algorithm is great, but that's not the important point. The important point is the underlying data. We are introducing what we call IP lifecycle management. Because at the end of the day, managing data, it's about managing IP. If you think about it, some of our industrial customers, take the big names of the industry, every single day they are receiving data from their suppliers. How do they decide what are the rights that they have on such data? Can they do learning on such data? Who has the IP of the derivative learning that has been made on data or corpuses of data that they have aggregated? If you are not capable of tracking IP ownership and IP lifecycle on the data, then you're shadowing massive risks with the world of AI. But to do that, you need two things. You need the ability to manage IP, so at the corpus level, to define who is having the IP on what. Two, you need to have very advanced data lineage models. Because ultimately, you need to know for any given model what was the data that was used for the learning, so who has the IP that comes out of it. There is a second effect behind that. And the second effect is very valid for the one of you that are working in regulated industries. Because if you cannot do detailed lineage, you will never be able to certify an aircraft using AI. You will never be able to certify a medicine using AI. Because if you start using AI for regulated industry, you need to be able to know what model you have used that had learned on what data at any moment in time where you have used AI as part of your process. So you need that level of traceability if you want to do AI in regulated industry. And I would like to add a final comment on this chart. If data is intellectual property, then it needs to be protected. So it needs to run on sovereign environment. And this is what we are also offering at Dassault Systèmes, is sovereign, secured environment that hosts all of this data with the most advanced, up to military credentials. So, obviously, I'm going to show you some examples, practical examples, and I'll try to illustrate, how these examples are shadowing reduction of non-recurring cost, reduction of robustness for supply chain, or performance of assets, like predictive maintenance for aircraft. And I'll take two specific examples. Everyone in the many conferences I've been to, they're talking about use cases. I mean, we don't talk about use case because we have a portfolio. So we talk about the portfolio of out-of-the-box solutions that we have that are built with AI. There are many examples on that screen. If I wanted to highlight some of them, you could start by the bottom left. Here, as an example, we can do quantum mechanical simulation to model and simulate new materials for batteries, as an example. If you go here, this is about unleashing the ability to investigate space of opportunities for design and assembly, doing generative design, generative 3D modeling. If you go here at the bottom, generative requirements, think about it. You take requirements that are mostly in papers, that can be digital papers, it's called a PDF, but still it's a paper. And we can transform that paper into a model-based document that can actually be simulated. If you go on top, then you have all of the optimization of the factory flows. If you go on the top right, this is about predictive maintenance. So this is just a small list of some of the generative experiences that we have introduced in the market in 2025. But let me take two examples for you. The first one, I choose to show you how we apply supply chain robustness in the automotive industry. And I took the examples of the tariff. You know, managing the tariff is a difficult problem. Because if you want to understand the impact of the tariff, you need to understand what is it that you put in each of your car, where and how you manufacture that car, and what are all of the suppliers that you are using that are fueling which factory from where at any given moment in time. So that's a difficult topic. So let me show you how we navigate into that by building the supply chain universes, combining the virtual twin of the product and all of its configuration, the virtual twin of the production system, and the virtual twin of the supply chain. So this is an automotive manufacturer that is buying for about 80 billion a year. There is, of course, an alert. There was an alert, but there is one every day these days on a new tariff, you know, from China. And the alert is informing the CFO on his mobile that there is a new tariff. But the virtual companion already is capable of pre-computing how much is the risk. For this company, the risk is 3.3 billion. It looks like a simple calculation. I can tell you to be able to do that assessment within 1 second is a difficult calculation. I've worked with many companies that are just incapable of, that are taking weeks to get to that number. Now the next step is how do I solve the problem? So the virtual companion is helping me identify what is the most relevant business process that I should start running across my organization to mitigate this risk. And it's, of course, pre-completing, you know, all of the steps so we can start cascading the task, you know, one after another. The first in play is the head of procurement. So the head of procurement, you know, he has a $3.3 billion hit. But the next question is, what are the most impacted programs? So he's capable of navigating now, scaling down from budget scale to production scale to understand program by program, car by car, what is the impact at the car level and what is the impact at the production level for that specific car configuration. He's capable of identifying priorities, program that he needs to start working, and this is now cascaded to each of the program leaders. The program leader is going down in scale. Now he's trying to understand within each of the car, what are the systems that are the most impacted. So here you can see the batteries, as an example, are coming from China. And for that specific car that is affected by 4,000 euro, the battery is one of the single biggest problems. So he can prioritize. He can decide, okay, on my program, I need to start working on the batteries, and I need to start working on this system and this system. And that is now cascaded to the commodity buyers. And for the commodity buyers, what we are doing is not only we are showing them the scale of the problem that they have to solve, but we are also using AI to identify all of the mitigation paths. So for that specific battery, do I have alternatives? Is there anything that I am buying that have similar capabilities that I am sourcing through other suppliers or through the same suppliers through other channels? And we can roll this down. You know what's important here is on that problem, I am capable of quantifying the impact of a new tariff at every scale, budget scale, car scale, production scale, part scale, screw scale, if I want to. And I can cascade the recovery actions to tens, hundreds of people, the whole of that within minutes. I can tell you, if you ask any companies how they are doing that today, it's Excel, mail, PowerPoints, and it's a mess. In most cases, I have no clue of the impact. I'm showing you examples here on tariff. 2 years ago, I would have shown you examples on raw material, price volatility. 2 weeks ago, I would have shown you the Nexperia impact. Last week, I was working on another shortage with a customer. Our customers are facing, on a weekly basis, volatility challenges that are massively damaging their business. The ability to do what I just showed, for some of them, has become a survival topic. So that is the first example I wanted to show. The second example, I'm going to show you how we use virtual twin, virtual companion, and AI for managing capital-intensive programs, infrastructure programs. I need to give you numbers. A nuclear power plant, as an example, it's 50 million assets, hundreds of kilometers of piping, billion scale in terms of number of attributes, hundreds of billion scale in terms of number of events that are affecting the construction of these sophisticated systems. So the first thing that we do, you have understood, is we take the virtual twin, and we are projecting on the virtual twin every single piece of data, engineering, costing, procurement, construction data, so that everyone is having a single understanding of what's happening on that program. The virtual companion here is helping me identify that I have a problem. I actually have a problem on a pump here that is not available. So it's detecting the weak signal and showing me the weak signal that I should be looking at. Of course, it is suggesting the agentic workflow that I need to start orchestrating across my teams to solve that problem. And by the way, he starts by, we're using another deep learning model here that is doing similarity analysis, finding, is that problem that I'm facing a new problem or something that I have already solved in the past, even if it was formulated with other language element. And by the way, how was it solved? You have understood this is a structured process, because here I'm working in the nuclear business, so it has to be regulated. But even in a structured process, you may have a unstructured conversation with experts here. So across that task sequence, we are orchestrating unstructured collaboration with experts, but in a form that this is fueling our learning process for the next problem. And ultimately, we can select the most relevant pump that should be used as a replacement, and we can place the order in SAP without ever logging into SAP. What is the takeaway here? Is I'm taking one of the most complex programs you can think of. I'm taking billion scale number of data and metadata. I am projecting everything on the virtual twin of the product, because the product is the only thing that everyone understands. That's an important statement. If you go into engineering, that's valid, by the way, in every industry. If you go in engineering, manufacturing, procurement, sales, everyone is using different language. In engineering, they talk part number. In manufacturing, they talk material number. They're not using the same language. The fact that we put the product at the center is unifying the language for everyone. And then when I do that, I'm then capable of starting to orchestrate work across team, because I have a single language, I have a single understanding for everyone of what's happening, and I can orchestrate at scale the execution of the task for everyone. And of course, we do that on sovereign environment, whether for a military aircraft, a nuclear power plant, in France, in the UK, in various countries. So that's what I wanted to share with you. Takeaway. It's about revealing the implicit, making it explicit and actionable. Explicit and actionable, it's about differentiation for our customers, and Virtual Companion and Virtual Twin are the way to access that explicit. It's not about algorithm, it's about data, and it's more about IP, managing the cycle of life of IP, and protecting IP, and lineaging IP, so we can use AI in regulated industry and protect the intellectual property of everyone. It's about empowering every single individual user, so they are more performing in what they do, and orchestrating work of teams, so that together, because they're sharing the same language and same collaborative process, they can be more effective. And by the way, all of what I did show you today are in production within all of our customers in the world. You've seen the list at the beginning.
Thank you very much. Can we get a round of applause?